All right, now we're going to go through numbers 1 through 8 of your review. Numbers 1 through 3, all you're trying to see if it's exponential growth, decay, or neither. So if I look at number 1, the first thing I want to see is if your coefficient is greater than 0. If it's positive, that means I can keep on going. So here it's a positive 2. And then in this one, it's that imaginary 1. And on number 3, it's actually a negative 4. The negative actually reflects it across the x-axis. So once you see that negative coefficient, you can automatically go ahead and put neither. All right, so second thing, what is being raised to the x power? Well, here it's a 4. Okay, so since it is greater than 1, I actually can go ahead and say we're growing by 4, multiple of 4 every single time. Okay, so it's being quadrupled every single time. So if this number is greater than 1, it's going to be an exponential growth. Another way you can check is to just go ahead and graph it on your calculator. So I'm going to go to y equals, clear that out. I'm also going to turn those off. I'm going to type in 2 times 4 raised to the x power, graph it, and we just looked at general shapes of exponential growth and decay. Okay, I'm going to zoom 6 after this stops working. So zoom standard. You take a look at the graph, see it's being drawn right there, see how it's growing over time. So I know that's exponential growth. For number 2, it's a little bit different. When we have our natural base, or e, it's being raised to a negative exponent. Remember, when it's being raised to a negative exponent, what happens there? It's 1 under. Okay? So if we take a look at this, my base is actually less than 1. Okay? So if that doesn't make sense, though, since less than 1, I would say it's decay. Make sure you go ahead and graph this. Graph the original on the calculator. So negative 0.35 raised to the x power. My graph. Notice my graph is declining, so it is a decay. Okay. So the negative exponent flips it down to the denominator. Now my base is 1 over e. It's being raised to the 0.35 x power. So 1 is growth, 2 is decay, 3 is neither. For 4 through 8, you're just rewriting. You're not actually solving for anything. So here we're going to change it to log form. So the base of my exponent is 4. So my base of my log is also going to be 4. So log base 4 of 1/16 is equal to negative 2. For number 5, the base is 3. So I have log base 3 of 27 is equal to my exponent of x minus 2. 6. Now you're going from log to exponential. So let's take a look at the base of your log. 3 raised to the 5th power is equal to 243. And these are actually really easy to double check, because if I do 3 to the 5th on my calculator, it equals 243. When you don't have a subscript, the base of your log, okay, remember it's 10. It's a common log. So 10 squared is equal to 100. And check to see if that makes sense. 10 squared does equal 100. When you have natural log, ln, your base, it's not written here, you have to remember that it's e, natural base. So e to the 8th is equal to x. Alright, so that's numbers 1 through 8. Make sure you talk to your teacher in case you don't understand one of these.